All right, so for our warm-up today, we're going to take a look at two different Siamese cats. One is two different cats. One is a Siamese cat named Sasha that weighs 13 pounds, and one is a Maine Coon cat named Phoenix who weighs 21 pounds. And so the question overall is who should the vet be more worried about? Who is more atypical to their particular species? So this has to do with yesterday's lesson. And in yesterday's lesson, we learned something called a Z-score. And for those people who weren't here, the Z-score is how typical a certain data value is. So one particular X value is in comparison to the overall population of whatever that particular thing is measuring. So in this case, you can see in the pink and blue boxes that they give you the data for the overall population of that particular type of cat. So Siamese cat has a mean of 8 pounds and a standard deviation of 1.9 pounds. Whereas a Maine Coon cat, much bigger cat, has a mean weight of 17 pounds and a standard deviation of 2.4 pounds. And just a reminder again that standard deviation measures the spread of the data. So the larger the standard deviation means that particular cat has weights that are more spread out, that particular cat type. Okay, so Siamese cats have a lower mean and a lower standard deviation, meaning they're more consistent and overall weigh less. Maine Coon cats, larger mean, larger standard deviation, which means they have a larger spread and overall weigh more. And then if we want to specifically look at how typical these particular cats are, we need to calculate their Z-scores. So I'm just going to write down again a little reminder about what the Z-score particularly measures. So we wrote this down in yesterday's note, but just to remind you again, the Z-score is a measure of how typical a specific value is. Oops. In comparison to the overall population. And the formula that we wrote down in yesterday's note for the Z-score was it's the difference between the particular value and the mean. So X is the particular value, mu is our mean, and it's in terms of standard deviations. So that's divided by whatever your standard deviation value is. Okay, so we're going to calculate this for both individual cats. So you can pause now, go ahead and calculate both of their Z-scores. Okay, so hopefully you have calculated them. Let's just check your work. So for Sasha, we go X of Sasha, which is her weight, divided by, minus the mean of Siamese cats, divided by the standard deviation of Siamese cats. So Sasha's weight was 13, subtract 8, divided by 1.9. Don't forget to make sure your calculator does the correct order of operations. And we get that Sasha's Z-score is 6.23. Similarly for Phoenix, we take Phoenix's weight, subtract the mean of Maine Coon cats, divide it by the standard deviation of Maine Coon cats, which was 21 for the weight, 17 for the mean, 2.4 for the standard deviation, and we get Phoenix's Z-score of 1.67. So we can see that Sasha is more standard deviations away from the average for her breed. So that means she's considered more overweight. Okay, so today we're going to be carrying on with this. Yesterday we also drew the graph of the normal distribution, and we talked about the 68, 95, and 99.7% values, and that was the area underneath the curve between 1 standard deviation plus or minus, between plus or minus 2 standard deviations, and between plus or minus 3 standard deviations. And so we were able to calculate some probabilities based on that. But all the examples we did yesterday were specifically within 1, 2, or 3 standard deviations. Now we can see for these two cats they don't fall nicely on an interval away. So that's where today's lesson comes in. So today's lesson is simply part 2 of the normal distribution, and we're going to carry on. So just a little reminder again, if you weren't here yesterday, this was the graph that we drew yesterday. Make sure you get that note from somebody. And so again, as I was saying, plus or minus 1 standard deviation away from the mean. So 1 standard deviation below, 1 standard deviation above. The mean is 68% of the data. So that means in this area that I'm shading in yellow, 68% of the area is in that yellow section. The 95 is plus or minus 2 standard deviations. So that would be this entire area that I'm shading in red. And then practically all is within 3 standard deviations. So anywhere in that green section is 3 standard deviations, and that was 99.7%. And we said practically all. Okay, but if we want to get values that are beyond that, we need to use something else. So I'm actually going to skip a slide here because we can actually graph one of those distributions, and then we'll talk about what that other big long chart is. So we're going to be looking at drawing the probability distribution for the Siamese cat. So in pink in the top corner there, I've just given the overall normal distribution key characteristics, remembering that this is always written as the mean, comma, the standard deviation squared. So that means the mean happens to be 8, the standard deviation happens to be 1.9. And again, that was the same data that was given right here, and they're both measured in pounds. So again, yesterday we talked about an axis of symmetry, and we talked about those key points that we can graph from plus or minus 3 standard deviations away. So the axis of symmetry of a normal distribution, again, remember that axis of symmetry is the center of anything symmetric. So that would be that dark line that I just drew, and it happens to be located wherever your mean is. So in this case, our axis of symmetry is at our mean of 8. So my axis of symmetry would be x equals 8. So that's where I'm going to center my graph when I start drawing my graph. Okay, and actually I can go to this next slide. We've got a scale drawn, so I can just draw my axis of symmetry at x equals 8. All right, but then to get my key points, I need to find 3 standard deviations above and below the mean. So the mean is 8. 3 standard deviations above that is going to be 3 times 1.9. 3 standard deviations below that is going to be, again, 3 times 1.9, but this time we are going to subtract that. All right, so then we go through and we figure out what those values are. So 8 plus 3 times 2 is 6, but then it's not 2, it's 1.9, so 5.7. So that will be 8 plus 5 is 13.7. And then on the other side, this is going to be 8 minus 5.7. So 8 minus 6 is 2, but it's not 6. So that gives me 2.3 to get that calculation. So now I can draw 2 points. One at 13.7, and it's going to be really, really close to the horizontal axis, but not at the horizontal axis. And one at 2.3. Really, really close to the horizontal axis, but not quite there. Again, because it's asymptotic. And then we're not drawing a second curve on here, so we're just going to draw our height at the top. We talked yesterday about we're not actually calculating the probability density. We're not actually calculating the vertical axis scale here. We're just using it relative. Skinnier curves are taller, fatter curves are shorter if you're drawing more than one on the same graph, but we are not. So we just try and draw our nice smooth curve. And again, it should be asymptotic, so you'll see there I kind of ran right into the horizontal axis, so I'm just going to erase and kind of smooth that out a little bit. All right, so that's how we're going to draw our normal distribution, and we want to, has it asked what we wanted to find out? Not just yet, but we can take a look at our original question, right? Sasha was Siamese, and she was 2.63. So if we look at that, that was a Z score of 2.63. Her actual weight was 13 pounds. So if we look back on this again, Sasha was 13 pounds. So she's right there. I can't use the 68 or the 95 or the 99.7 because it's not nicely on one of those Z score values. We can actually draw a second axis underneath here to show our Z score values. This is 0 standard deviations away from the mean because 8 was the mean. This was 3 standard deviations above the mean, so that's a Z score of 3. This was 3 standard deviations below the mean, so that's a Z score of -3, and we can split it evenly. That's not exactly an excellent scale on that side, not perfectly even. We should be trying to use a ruler and leveling those out, but close enough for this. So you can see, though, key idea that I'm trying to say here is we're between 2 and 3. So that's kind of annoying. But you can definitely tell that, like, there's not very many cats that are above her, right? That area, if I shade in, this area right here, that's the percentage of cats that are above that weight. Very few. So that means she is quite overweight in terms of Siamese cats. All right, but the first question we're going to look at actually is what percentage of Siamese cats have a weight less than Sasha? So we're not actually going to look at this yellow spot for above Sasha. We are going to first look at what percent have a weight below Sasha. So I'm just erasing what I colored in there so that I can actually color in the area below. So I'm just going to go through and kind of do some lines to shade it in like this. You can color it all the way in with a highlighter if you've got one, but that's kind of the idea. We are looking for the area of that section. Now, again, I said we're not going to do the calculus of finding the area under curves, but luckily we have people that have already done that for us, and they've made a nice looking chart. So that's where this other slide comes into play. Now, this slide on your photocopy is probably quite small, right? It's in your textbook, page 606, or it's on the back of the formula sheet. So come and grab a formula sheet so that you've got that and flip it over so you can look at the back of the sheet. You might see, depending on what version you get, some of them will go to 5 decimal places on the inside, some will only go to 4. Not a big deal. I will mark it correct no matter which one you get for that case. Okay? But what this chart shows us is the area of the curve below a certain Z score. And it shows us all of our Z score, smaller or less than 3 standard deviations away. This one actually shows smaller or less than 3.49 standard deviations away. I'm not sure if they all show that. Some of them might just go to 3. But anyway, we want to find what percentage is below an X equaling 13. So I'm going to start actually just by writing that key point down. I want to find the probability, we should define our X actually. So the random variable X is the weight of a Siamese cat. So we want to find the probability that X is less than 13. Because again, the probability that X is less than 13 is the same as the percentage of things that are less than 13. All right, but if I look at this chart, it gives me it only in terms of Z score. It doesn't give me it in terms of X score. Because X is going to be specific to whatever variable you're measuring. And so that's why we often call this, we're normalizing it when we're converting over a Z scale. Because our Z scale will be the same as long as it's that same shape curve. Okay? So we're going to use our Z instead. So if we look back up here, we knew that Sasha's Z score was 2.63. So back to my work here, I'm going to go probability that Z is less than 2.63. And that's going to be equal to the probability that X is less than 13. All right, so, but what does that mean? Again, that means the area that I've shaded in yellow on here is less than, right here, 2.63. That's the probability or percentage of data values in this population that is less than 2.63, whatever that area is. So in order to find that area, we go back to this chart and we learn how to read this chart. So we want to go 2.63, and it was positive 2.63. So we're going to look down the z-score line here, and this side is all positive. This other side is negative z-scores. I don't want negative, I want positive. So I'm going to go down this column until I get to 2.6. But I want 2.63. You'll notice across the top, that gives us our second decimal place. So 0.03 is there. So we're going to go down 0.03 over from 2.6, and that's going to give us the value that we are looking for. Okay, so take a second right now, look at your chart, go and grab one if you need to, and find that value and just talk it over with your group, how you actually got to that. Okay, so hopefully you paused and you took a peek at that. So if we go back to our actual work, so this was 9957. So we'll just go here, equals, change back to black, 0.9957. So we can say, therefore, the percentage of cats, specifically Siamese cats, that weigh less than Sasha is 99.57%, 99.6%. Like most Siamese cats weigh less than Sasha. Okay. All right. So let's just again reinforce what the communication piece is, because we need all of this. Okay. So this particular piece here is looking at probability that a weight, because that's our x, is less than 13. I can't look up a weight less than 13 on a chart, so instead I need to convert to a z-score. So this is now normalized. Normalized means converted to a z-score. And we're now looking for the probability that z is less than 2.63. That our data value is, or what's the probability that any data value has less than 2.63 away from the mean. Okay, and then the final line, that is the actual probability or percentage. So again, we need all three of those lines when we're communicating. You can't be skipping things. You need to make sure you have your equal signs. You need to make sure you have your capital P's for probability, all of that stuff. All right, so let's do example B. Now we're looking at greater than. So this is what I was shading in before. I've given you another graph just so that we can show what we're calculating again here and color that in as well. So this is greater than. So we want to find probability that x is greater than, oh, in this case we want 11 actually. We don't want Sasha's actual weight of 13. Switch the value here. 11, just so we can practice, I think, doing the whole piece again. All right, so we want to find probability that x is greater than 11 pounds. Well, again, I can't look up an x. I can only look it up after I've normalized it to a z scale. So that means I need to actually convert my x to my z. So z is x minus the mean divided by the standard deviation. X is 11. My mean, if we look back up here to remind us, is 8. And our standard deviation is 1.9. So So that gives me a Z of 1.58. So now I'm going to convert my probability statement from an X to a Z. All right, now the only problem is when I look back at my chart, the chart diagram, both pictures show me that it's less than. Your probability distribution chart for normal, all these data values, is always a less than. So I can't actually look up a greater than, but I know the total area. What was the total area again? Total area was 1 or 100%. Okay, so if I know the total area and I can look up the area below, that means I can find the area above. So then I'm going to shade in the area below in blue, just so that we can kind of follow along with the coloring. So the red area is going to equal 100%, or 1, minus this blue area. And the blue area is probably that is less than 1.58. And then we just look it up. So take a second, go and look up what is the probability that Z is less than 1.58. Okay, so hopefully you kind of got that same section as me, so 0.9429. 9429. And then we just do the subtraction. So that means the probability, or the percentage, of Siamese cats weighing more than 11 pounds is only 5.7%, 5.71. Okay, so again, it's a small percentage, right? You can see that red area is a small percentage. I'm just gonna circle this in red because that's my overall probability that I wanted. That's that red area. And this is that blue area. I should have wrote that in blue just to make the little connection. So if you've got a highlighter, super helpful to kind of highlight so you can see all of those pieces. But again, every single one of those lines is needed. Okay, so you need to show your different probability math paragraph, and you need to show your Z-score math paragraph. Pause if you need a second to finish copying that down. And then we're going to do one more example where we look at what happens if we want a probability between two values. Okay, so this one says between 5 and 10. Again, I've given you another sketch so we can sketch in these key values. So 5 pounds would be right here, and 10 pounds would be right there. And so we want to find this area. All right, so first thing I'm going to do before I even write my probability statement, I'm going to convert both of these to x's. Or I'm going to convert both of these x's to z's. So my first z here, I'll just call that z1, is going to equal my first x value, which was 5, minus the mean divided by the standard deviation. Again, the mean is still 8, standard deviation is still 1.9. So my first z-score there ends up being negative 1.58. And then my second z-score is going to equal my second x value minus the mean divided by the standard deviation. So I want you to pause here and go ahead and calculate this second z-score, and then start playing again so you can check. All right, so hopefully you got those same two z-score values. So now we're going to look at, all right, how can I use this to calculate a probability? So again, we want the probability that x is greater than 5 but less than 10. But I can't look up the x, so that's why I converted it to these z's. So I want the probability that z is greater than negative 0.58 but less than 1.05. All right, but there's no chart that tells me a between. The chart only tells me below. So I need to shade in the two belows. So if I look at below 5, that's this section. And then I look at below 10, that's any of this. And I got to figure out how to use green and yellow in order to get the black. Let me just redo the black so it's kind of on top so we can see what's going on there. All right, so how do I get from a green area, which I can look up, and a yellow area, which I can look up, because both of those are below, in order to get this black? All right, so in order to do that, hopefully some of you can kind of get that idea. We first need to look up the green area and subtract the yellow, and that's going to give us the black. Okay, so the green area was probability that z was less than this second z value of 1.05. And then we're going to subtract the probability that z is less than this first x value of negative 1.58. And I'm just going to circle those in yellow for the 1.58 and in green for the 1.05. Okay, so those are the two areas, and that in total is going to give us, after we do the subtraction, that's going to give us the black area. So pause, look up those values, do the subtraction, and see if you can figure it out. All right, so hopefully you got 79.6% of Siamese cats weigh between 5 and 10 pounds. All right, that is the end of the lesson for today. Your practice work is on your unit outline, which is on your Google Classroom, and it is textbook work. And don't forget to bring in Scrooge cans tomorrow.